The essential question is, how do Newton's laws describe interactions between objects?
The normal force is a supported force exerted upon an object that is in contact with another stable object. It is also perpendicular to the surface. In this case, we have a cat resting. We have the surface, the dot as the cat, and the normal force going up. The symbol of the normal force is Fn. That's why we use Fn in here.
We have the applied force every time that an object is being pushed or pulled by another force. Here we have the cyclist, and as the cyclist pedals, we have an applied force to the respective direction.
We have that frictional force is a force exerted by a surface as an object moves across it. So here we have the motorcyclist. As he moves, the street makes a friction force to the opposite direction.
Gravitational force is a force that pushes everything to the earth. As an example, we have a guy falling in a parachute, so his gravitational force is pushing down.
We have an air resistance or drag force as the frictional force that acts upon objects when they travel through air. Here we have the guy on the parachute again, and as he's going down, the air resistance goes the opposite way. The tension force happens when we have a force that is creating tension. In this case of the monkey, it is hanging on the branch, which means the tension is made in his arms. So here I have the monkey and the tension forces.
Spring force happens when an object is pulled or pushed by a spring. In this example, we have the little horse being pushed by the spring. So here it is, the spring force.
Mass is a quantitative measure of inertia, and the weight of the body is equal to Fg, which means the gravitational force. And the gravitational force is the mass times acceleration due to gravity. So the weight changes from place to place, while the mass remains the same. As an example, I have the cat. His mass is equal to 1 kilogram. I have that the acceleration due to gravity on the Earth is 10 meters per second squared, and the one in Saturn is 10.44 meters per second squared. If I take the cat to the Earth, I will find his way through Fg equals mass times acceleration due to gravity, and that will give me Fg equals 10 newtons. If I take it to Saturn, I'll use the same formula, and I get that my weight is 10.44 newtons. It is important to remember that the mass does not change, so I have it as 1 kilogram in Saturn and in the Earth.
Newton's first law says that an object at rest tends to stay at rest, and an object that is moving tends to stay in motion with the same speed and direction unless acted by an unbalanced force. In this case, we have a book standing on the table. It has its normal force and it has its gravitational force pushing it to the earth. As both have the same magnitude, the net force will be Fn minus Fg equals 0 because their value is the same. What changes is their direction. That is why they are balanced.
The Newton's second law states that for every force, the acceleration of an object is directly proportional to the net force and inversely proportional to the mass of the object. The direction and the acceleration are the same. As a scenario, I have the cyclist, and the cyclist is speeding up. So, my FA and my FF have different directions and magnitudes. The net force will be FA minus FF equals MA. Therefore, FA equals MA plus FF. My acceleration is 8 meters per second squared, the mass is 80 kilograms, and the friction force is 23 newtons. Doing the math, I find that FA is equal to 663 newtons.
The Newton's third law consists on saying that when an object exerts a force in another, the other object exerts a force in the first object with an equal force but in opposite direction. That means that the forces are balanced. We have that the monkey is pulling the branch down. That's the action. The reaction will be the branch is pulling the monkey up. The other example, the action is the guy with the blue shorts pushes the hand of the guy with the brown shorts to the right. And the reaction is the guy with the brown shorts pushes the hand of the guy with the blue shorts to the left.